Hey everybody, welcome to From A to B. You have Shiva here. I'm a senior strategist at Spiro, and I'm super excited to welcome Stewart on this topic. Specifically, the intro came from discussing prioritization frameworks and road mapping through LinkedIn. I wanted to have you on here because I think you have a specific engineering slant of this that I really want to dig deeper into. So Stewart, maybe you can give a couple minutes about yourself so we can know, why should I talk to you? Why should I trust you?
Sure. Hi, Shiva, and thanks for having me on the show. So I'm Stuart. I'm head of experimentation and digital data engineering at RS Components. We're a FTSE 100 company, and we're a global distributor and solutions provider of electrical components, parts, stuff that goes in planes and space and trains, and we got stuff everywhere. We work with some really huge businesses and organizations. Yeah, I mean, my background is in software engineering. I started my career as a developer building WordPress websites and things like that. And I suppose I fell into the experimentation space by being inquisitive and kind of just thinking, well, of these features and things that I'm building, what is the value of them? How do I measure that? And then you get into the data world, the analytics world. But I've always kept the engineering background. I've always been really obsessed with making sure that experimentation as a process works for engineers. I feel that engineering doesn't get a lot of love in the experimentation world, despite a lot of movement away from client side in recent years to server side. We've had great success in RS Components in driving experimentation as an engineering standard and practice. And I want to share that with the world. So I'm happy to be on the show and happy to talk with you today.
Yeah, that's a great topic because it's interesting that I think, I talked to someone else, Kenya, who was previously in experimentation and transitioned into PM. And as a result of that, it helped create the voice of advocacy for experimentation as a PM. And in the same way, you're almost doing the opposite, where you're Trojan horsing engineering into experimentation so that it has a voice, when a lot of times it's kind of like a silo, so to speak, of here's the test, and then it's kicked off, go build it exactly how the way I wanted to build it, rather than it should always be this collaborative process of we have ideas. Hey, design, help us see if we can realize these ideas. In the same way, engineering, we have these ideas. Help us make sure that we're going to be able to execute the idea and make it a reality without totally breaking the system and making you guys spend 7 sprints to design this kooky concept that we have. So I totally love that perspective. I love that career path. I think it's something that I think a lot of CRO people tend to overwork in engineering is to experimentation. You guys are our friends and partners. You're definitely not our enemies.
Absolutely.
Specifically, I think that's the kind of point that we were talking about on LinkedIn that I wanted to start probing about. It's more just roadmaps and prioritization frameworks. And I wanted to geek out a little bit with you on prioritization frameworks. Specifically, every company should have their own unique prioritization framework, I think, and it could be loosely based on, a PXL framework, a RICE model, ICE, whatever you want to call it. But the thing I want to geek out a little bit deeper with you is thinking about code complexity and running experiments. So, and like prioritization of those experiments. From my experimentation perspective, that's not heavily engineering focused, is that while I think there might be times to deprioritize or prioritize, or let me say this. While I think there are times to deprioritize complex experiments, I'd say there are also times to prioritize those complex experiments because sometimes complexity yields big lifts. But that's not always a rule. It always depends on the test, on exactly how it's going to be built. And at times, I will want to swing big based on data and build out this big test. But my perspective is I tend to deprioritize complex tests in general, unless there's a very good reason, because if it's quicker to build, the insights that can be generated will ideally come quicker. And at times there's trade-offs, but for the most part, there are some good tactics that you're able to deprioritize complex tests, prioritize the less complex tests, but still test your hypothesis quicker and not require so much in engineering, which I would think would be a generally good thing for the engineering team. So what are your general thoughts to that?
So I can't disagree with anything that you've said because you're absolutely spot on. Everything in experimentation principles leads us to believe that we should always be focusing on the fastest path to prove or disprove a hypothesis. In that regard, we should be doing as little work, which could potentially be wasteful, before committing more engineering resource, analytics resource into a bigger or hairier piece of work. So on that point, you're absolutely correct. I think the one thing that kicked off this discussion between us on the LinkedIn post and where I was coming from is that complexity for us means more than just the number of lines of code that are actually being written by engineers. So complexity can also include how difficult is it to get the data that you need to measure against that particular outcome or hypothesis that you're proving or disproving. In some instances, experiments become complex because you're asking a really difficult question and your hypothesis can be based on metrics that you as a business might not typically be geared up to collect. So that could introduce complexity to the experiment. You can also introduce complexity to an experiment through the increase in the number of variations that you deliver on a particular test. I'm a big believer that you should always move away from A versus B and try to get a C, a D, an E in there if you can. Obviously, it depends on your test power, right? And your ability to be able to do that. But as a general rule of thumb, particularly when you're early on in the exploration phases of a hypothesis, running multiple variants for a test, which does increase engineering complexity, no matter which way that you look at it, you've still got, in a server-side world, you've got engineers writing more variants and coded variants. In a client-side world, you've got more declarations in your WYSIWYG editor and moving things around. Still more complexity there either way. However, there's this trade-off between complexity and the amount of learning that you're going to get from that particular test. And I think where it's possible that some programs could go wrong is they bias too heavily towards simple tests and less variance. Where actually, if you dial up the complexity just a little bit, you get a lot more bang for your buck by increasing on those variants. So that's kind of the foundation of the principle that we hold. And I always try to encourage the teams that we have to think outside of the box. Okay, you've come up with an A versus B. What other solutions could exist that might yield to new insights and new learnings for our business that we might not have conceptualized before? And actually, it's in those out of the box thinkings where most of the value comes from.
Yeah, I think that's a great point about quality versus quantity and like velocity versus complexity, because the more tests you run, in principle, the more learnings you get. But there is a layer of, complexity to achieve the velocity, and you're decreasing the quality at the trade-off of quantity, which if you dial it exactly in the opposite direction, where you're focused exclusively on quality and ignoring quantity, then you're not balancing the learnings with, the complexity. And it'll take, a month for you to develop one test. And if it doesn't win, it's a lot of kind of wasted potential. So there's a fine line in the middle of like fine tuning between the balance of quantity and quality. And I think if you scale far towards one or the other, you're in a problem. So I totally agree there. You touched a little bit about this, adding variations to experiments. And I think that's a topic that's particularly interesting to me because I agree with the principle of testing maybe an additional variation or two could be beneficial depending on the power of the experiment. What unfortunately it does is as you add more variations, it adds the chance for false negatives, false positives, false negatives, math-wise, which again adds a little bit more complexity. But I do agree with the principle that sometimes the ROI of adding one additional variation is greater than doing a whole other A/B test where you're adding control again and you're putting more traffic into the control again instead of adding an additional variation to compare. If you at least have good statistical principles to control for it, make sure you have that sample size, then you're probably in a better spot. But I think there's a fine line between which I think you don't disagree with. There's a fine line between, hey, maybe just one or two variations and like, hey, let's add 10 and just throw everything at the kitchen sink to see what happens. Fair?
Yeah, absolutely fair. And I mean, hey, I don't even think we could, with the huge volumes of traffic we have at RS, which is, millions and tens of millions of unique visitors per month, I don't think we could even split down on some of our highest traffic pages to 10 variations. there is certainly a limit, right? And variations don't necessarily have to be entirely differently coded solutions or implementations. We've had a huge amount of value from just challenging our thinking on the positioning of certain elements. We ran, I remember one test that we ran that was really all 4 variants that we ran of the test, which was introducing a new element to our product page, which is one of our highest traffic pages. All of those variants won against the control, but the delta between the sort of the smallest winner and the highest winner was almost by a factor of 4 or 5. Now, we could have easily done an A versus B in that scenario and kept the complexity down and said, you know, we're just going to do one variant and try it. Now, had we done that, I think in aggregate, it would have been something like a 9% increase on our primary metric for that particular experiment. But in reality, we found a 36% increase on the primary metric with one of the other variants. Now, as experimenters, you know, you would take that 9% and you'd still be happy with it.
Yeah.
But would you, in your series of prioritization, the way you think about it, would you have taken that 9% and gone, maybe we could get more out of that and run another test? Probably not. You might have gone down a different path. You might have focused on something else. And actually that huge insight that we got from just turning up that complexity dial just a little bit more, it always yields fantastic results for our business. Either way, if it's a win or it's a positive impact or a negative impact on the primary, you're still learning more.
So I'd politely disagree on that. And my pushback to that point would be, if you're running, and this is more kind of core to me in my philosophy of test to learn, where every test you run generates an insight, win or lose. If you are running that process of, you know, instead of doing 4 variations, or maybe you're aggregating piecewise and taking a concept and saying, all right, it's going to be, you know, I'm going to test the scale of disruption and test incrementally, pushing that concept further in that single test, which I think that's kind of what you're talking about.
To an extent. I mean, it was actually more of a, interestingly enough, it was more of a disagreement, right, internally, where we're talking about a particular feature and the positioning on page, and, you know, an organization of our size, you've got a lot of complexity around, you know, people with lots of opinions. So well, let's try them all and see what the value is, right?
Gotcha.
But your example is true as well. That is also something that we do, and that I know that other extremes do as well.
So the reason I was pushing back on that is to say, I wouldn't ever just run a test, call it a winner, and then just leave it. For me, it's always the iterative process, because capitalizing on the wins yields you even bigger wins. So continuing to push forward and iterate in that concept has shown incredible success for me. So I think if you're, the mindset I think you would have regardless is, if you have a test win, you would never just leave it and be like, we did it. Like even the 36% or 39% lift, the number that you had, I don't think you just called it and you're like, done, never going to touch this again, right? You're always going to continuing to be iterating. And I think it's a trade-off between like risk and cost of like, if you do that smaller iterative approach, we're only testing A versus B or A, B, and C, your risk is technically probably going to be a lot less, versus if you test those variations and all of them lost, then it's what, 75% of your traffic that's in negative instead of just 50% at a smaller scale. So I think what you're kind of doing, I don't think your way is wrong. It's more it's an acceptance of disruption in a good way, that you're swinging for the fences. You're not going for a first base hit. You're going for the home run in a controlled way. Obviously, you're experimenting. Yeah. Is that fair to say?
I don't think it's unfair. I mean, I'm picking said about you know, cost and risk, and that's certainly something that in our business we laser focused on, and we try to mitigate against. So one of the big benefits of experimentation that I'm always talking about, both internally and externally, that people often forget about when it comes to engineering resources, that when you run experiments, you're able to either prove or disprove whether investing more time, you know, operationally is actually worth your business doing so.
Right.
And you know, we've had instances where we've had assumptions from product managers and things like that of large, lofty features that might take a number of sprints to build. And actually, we've challenged that and said, hey, let's take it down to a simple experiment and see, you know, if there's merit or if there's not. And when there is merit, great. You know, we double down on that. We invest in that. That's where we spend our time. And when there's not, then we kill it and we move on to something else. And that's one of the benefits that is often missed. one build on that complexity piece really worth noting about is that sometimes when experimenters and program managers or product owners or whoever it is that's kind of driving your experiment agenda, when they are looking at complexity, it can often be quite a biased metric, because my understanding of complexity of a particular test might very much differ with your understanding of the complexity of a test. And sometimes when we're prioritizing, we also don't know exactly what the solutions or the variants might be. And that's kind of a more of an evolutionary process as you kind of go through building a comprehensive test plan. A test that you might have originally thought was quite simple could become complex later on. This has been a problem for us, and it's led to things that go into build that end up being bigger or hairier than we thought. So we've kind of got a middle way process where we're bringing down that engineering complexity. And if the answer to that question is, I don't know, we say, okay, well, that's great. Pause, let's go do a spike and actually spend 1 hour, 2 hours of an engineer's time to look into that particular piece. What's it going to take for you to deliver on these types of solutions? What's the complexity of the code base? You know, what about the metrics, various bits and pieces like that. And over time, doing those activities has led to more accurate complexity scores for us that actually helps, you know, those in the decisioning seats about what they prioritize to make a more informed decision, rather than just it's a 1 or it's a 5, right?
Right.
It's got a bit of color to it.
Yeah, I want to probe a little bit deeper into that, because I think growing an experimentation program is complex. When you think about the maturity of a program, you know, you start potentially as a one-man team trying to optimize as much as you can without a dedicated tool, without any dedicated designers, developers, starting to scale up as you move towards higher maturity, higher complexity. One of the biggest roadblocks I've always hit is engineering, having that dedicated capacity to run a test. Just anecdotally for me, but I'm sure that's shared with a lot of other different people as, man, it's hard to get experimentation buy-in on the, not hard, I'm sorry, let me say it differently. It's hard to get the dedicated resourcing for engineering.
Yeah.
Because a lot of times, you know, the product managers or the product owners are like, well, yeah, but this is an unknown. We have to build this thing because of X, Y, and Z. And it's sometimes you have to build a business case. You have to like educate the project managers and owners, et cetera. But I think your perspective of being the engineer transitioning to experimentation is valuable in like, what are some tips, tricks, or thoughts you have around an experimentation person trying to grow a program, but realizing that engineering is their limiting principle? What are your thoughts?
It's a great question. So I think the first thing to note is that engineers are humans too, right? And it can
Are they?
Yeah, well, they might be superhumans. I mean, they understand stuff on a very different level to the way that we might, but engineers are humans too, right? And in many engineering outfits that aren't outcome-led, data-led, and experimentation-led, you find that engineering functions are typically considered to be feature factories, where you have requirements that come in from the top level of the business, get fed through product managers, and then you end up with long, lofty roadmaps that probably go 12, 18, 24 months into the future that says, we're going to go from A to B to C and march through to our inevitable victory by delivering all these features, right? Now, in that world, in that environment, you've got engineers who have Jira ticket after Jira ticket, and they're just trying to slam through them all as quickly as possible, right? That ticket's done, move on to the next thing, that ticket's done.
Yeah.
No engineer that I know wants to work like that. Any intelligent engineer actually wants to know what the value is of the work that they're delivering, right? Fundamentally, they're delivering features and they're delivering changes to customers.
Yeah.
You can't imagine how gutting it must feel to spend, I don't know, 20, 30 weeks on building this big feature, and then you deploy it and you find out it's dropped your conversion rate by 10%, right?
Right.
What a waste of time. And as an engineer, you would feel like, I wasted all this time building this feature and no one likes it, right? It's not doing anything for our business. It sucks, right?
Yeah.
So no engineer wants to work in that way either. So when you think about those two things, it's kind of like, well, experimentation is the answer, right? You can say to engineers, well, you don't have to build things that take 30 weeks and then you release it and you figure out if you cross your fingers and pray, did it do something or not? You don't have to work in that way. You can have that instant feedback from customers, or relatively instant. You know, it's not lagging feedback, right? It's a much faster feedback mechanism of the value of what it is that you're doing. And you also, most importantly, have a seat on the table in terms of your ideas and actually what's working for you. And you know, you're an expert in building, you know, these types of applications and interfaces. What do you think, right? You've got a seat at the table there. So I think when you think about all of that, and when I think about the journey that we've been on, which has been very engineering led, but of course we've had to massage with product, we've had to massage with executives in the business. You can't get away from that, right? You need everyone to be on board. Right. When I specifically think about engineering, it's really about getting away from being a feature factory, understanding the value of your work, and getting a seat at the table. I think those are the three key things that stand out to me, that if you speak to any engineer worth their salt, they'll care about those topics.
I love that feedback. You know, it's something that I've been talking a little bit about with like experimentation, working with UX people, UI designers, that a lot of times it's seen as combative because it's me being an engineering or an experimentation person, basically trying to test someone else's hard work, sweat, and tears, and then showing quantitative data to say, your design sucks, and here's all the data supporting it. That's how sometimes it can be perceived. Just like you said, engineering are humans as well, although we'll figure out what the semantics are about. I'm kidding. But UX people, UI people are also humans. And like, of course, if like they come at it with like, we are going to prove how terrible your design is, or we're going to prove how great it is, sometimes it could be seen as combative, when instead it's a partnership. It's a partnership where you're working with the UX, you're working with the UI to say, I want to take your idea and test it so you can show this paper and show this test doc to your boss to help you get a bonus at the end of the quarter. And that types of stuff, in the same way, that partnership should be there with the engineering team, especially when those people, you know, the perspective, it totally got lost on me, and that you helped me realize this, is that, you know, a lot of times they're building stuff and sometimes they're so far removed from the process. All they're seeing is Jira ticket build, Jira ticket build. And they like to be connected to the things that they're built, right? You don't want to just like build a Lego masterpiece, but then only just see like the little piece of it without looking at the whole thing to be like, damn, this is pretty cool. And actually seeing the efforts of your work roll up into the bigger thing, which I think product owners try and do. But in that same way, experimentation should approach that with engineers to say, we don't want you to work hard to build something that we don't even know if it's going to work or not. We want to chunk it down into something smaller so we could prove it's worth your valuable time to move it forward, and have that be a street to say, hey, remember that thing you helped me build? 13% lift to conversion rate. Let me buy you a drink. Like stuff like that. That's a partnership that you help build this relationship with that engineering team and give them a voice to say, you know, I think you might have some thoughts on this, but like process wise, it should never be, you know, everything happens and then it's literally a Jira ticket to the engineering team to build. Process-wise, that engineering person should be, just like you said, have a seat at the table to help dictate the conversation, dictate complexity, and they could even work in to say, this isn't feasible, but guess what? If we just trimmed it down to this, it's really easy for us to build. And I think that's where full circle conversation for me is like, that's where I think when I think about prioritization frameworks within engineering, I tend to deprioritize complex tests to try and help the engineer. So that we don't have to build something complex. Let's look for reasons to make our hypothesis be tested, but not have it be so complex on the dev side, not have it be so complex on the UI side, while still being core to the hypothesis.
Absolutely. But your good engineers, if you involve them early on in the process, might challenge your understanding of what is complex and what is not complex.
Totally.
Right? And the funny world of software delivery, right, is that if you say to a group of engineers, go build me this thing and I need it in 300 days, they will take 300 days to build that thing because they will have all the time in the world. They'll make it as complex as they want and they will use all of that time up, right? But if you say, build me this thing, but you've only got 2 hours to think about it and do it, all of a sudden then you flip this switch in kind of the ingenuity side of your brain of, God, I can't do it in the more complex way. Is there a simpler way that I can look at this? Can I do some refactoring here? Can I make just something a little bit more simple, right? And that is where really being in touch with your engineering teams and having good engineers early on in the process can help you turn what might be complex tests into something that actually meets your original requirements, but in a way you might not have even conceptualized. It is MVP. It's taken a couple of hours of engineering effort, but bringing them to the conversation, getting them a seat early on in the conversation there, always yields huge benefit in my experience.
Totally. Awesome. Well, Stewart, thank you so much for taking the time to kind of brain dump all of this engineering stuff. Definitely a fresh perspective for me for a lot of things I hadn't truly considered from the engineering side. Anything you want to plug? Anything you want to quickly talk about?
Yeah, so I'm trying really hard to post more frequently on LinkedIn and maybe follow in your footsteps a little bit, Shiva, and talk a little bit more just about what we're doing at RS Components, which I think is really exciting and interesting. So if you want to follow me on LinkedIn, it's just Stewart Ehoff. I'm one of very few Ehoffs in the world, and if you do find others, they're probably related to me. So go hit them up as well. Why not?
Thank you so much, Stewart. I really appreciate you taking the time here.
Thank you, Shiva.